Hello, everyone. Welcome to module H6.2, which is the continuation of our module from last week. And today we're going to talk about the a priori and a posteriori methods to compute TPU, or basically the total propagated uncertainty, whether it is in horizontal or in vertical. So the first thing we have to know is what are a priori and a posteriori. So these two are actually Latin phrases used to distinguish types of knowledge, justification, and arguments. So basically, when we're talking about a priori, we're talking about something that is coming from the earlier, so it comes before something else. So it literally translates as from the earlier. And then the knowledge is independent from experience. So it's basically more theoretical than experimental. And the example, for example, it's mathematics, because in mathematics, you know that 1 plus 1 equals 2, but you don't have to have an experience, because there's no physical experience of 1 plus 1 equals 2. And the second one would be a posteriori. This one literally translates as from the later. So if a priori is basically something that came before something else, which is prior to something else, that's why it is called priori. A posteriori is something that comes after. So that's why it's called posteriori. So it's post of something. And it's basically a knowledge that depends on empirical evidence. So there must be a physical evidence, or you have to see it happen, because that's why it's called something that's after. An example of this would be physics, because anything we are talking about in physics, it needs to be, it has to make sense in our physical world. When we're talking about gravity, it has to make sense that if the mass is greater, then the gravity pull would be bigger, for example. So how do we apply a posteriori and a priori in hydrographic surveys? So we apply both types of knowledge when we compute THU and TVU of a survey. So for example, if we're talking about a priori, as you can see, that we actually define a theoretical value based on the best practice estimation prior to the survey. So for example, if we are going to a survey, we've got one positioning system, and then we will have an INS, then we will have our own transducer, and maybe we will have other other measurement instruments like a magnetometer. Maybe we will have side scan sonar. We will basically count, the uncertainty of each instrument, and then we will basically predict the theoretical value of the THU that we will have if we've got certain numbers of instruments. So as I said, we can compute them from the uncertainties of each instrument, as well as maybe the environmental influences. So we can make our own weight. For example, if the weather is good, then you can say that, well, maybe the weather doesn't really have anything to do with the results of the survey. But if the weather is bad, then you need to take into account in it, however it is. So, and then you can actually improve your a priori THU and TVU while you're doing the survey. So for example, if you're doing a survey in the morning, and in the morning the weather is good, then you can just say, okay, this is our a priori THU and TVU. It's based on what we have in the instrument. But for example, if at night we continue the survey and the weather is really bad, then you need to assess your THU and TVU. Is it still good, or do we need to have like a greater error budget, for example? So that's basically how we use a priori. So for a posteriori, as you have known, it will be computed after the data is collected. That's basically what we did yesterday in our practical. So we already have the data, and then we will check afterwards if it actually complies with our THU and TVU. And basically, it's always better if we compare what we've got from the field to our theoretical value. So we can actually check if our survey have actually complied to the standards or not. That's basically it.